Here we're doing an application problem with interest compounded continuously. So for part A, we are being asked to find the derivative of A of t. So we'll have our 4,000. And when we have an e to the u situation, we want to find the derivative of the exponent, which in this case is 0.06, and multiply that by e to the u. So 4,000 times 0.06 will give us 240 e to the 0.06 t. All right, moving to part B, we want to find and interpret a prime of 9, including appropriate units. And it's also going to want us to round to the nearest dollar. All right, so all we're going to do is plug in 9 for t. So we'll have 240 times e to the 0.06 times 9. That gives us $411 and around 84 cents, but since we are rounding to the nearest dollar, that's going to be $412. And what this means is that the $412 increased in the total amount per yearly increase in the investment time period. And finally, we'll look at C, which wants us to compare the approximation of 412 to the actual change. Now, that's where I want to point out that we're comparing that to the actual change. So the actual change formula is the one that we're given in the beginning. So we'll start by finding A of 10. That gives us 4,000 times e to the 0.06 times 10. And this one, they are asking us to round to 2 decimal places. So that will give us 7,288 dollars and 48 cents. And then we'll find A of 9. So again, we use the original formula, replacing t with 9. And that will give us $6,864 We want to subtract these so that we can find the actual change from 9 to 10, and that gives us $424.45. So the actual change is $424.45. And looking at our approximation, $412, we're pretty close. Hope that was helpful.